This presentation is designed to be delivered to students to inspire them to study physics and astronomy. It contains a variety of JWST discoveries from Mars out to the beginning of space and time. Each discovery has a reference list along with this PowerPoint provided at this download QR code, which will be repeated at the end of the presentation. We seem to be getting some interference from outer space. Wait. Oh my, it's C3PO. What in the world are you doing?
Welcome to this session of the James Webb Space Telescope. This telescope can see stars more accurately than I can, which makes me angry. I hope you enjoy the presentation, and students, make sure you follow up with research from the reference list.
Each slide has references for further study of the discoveries. The goal of this presentation is to inspire the audience into further reading and research by looking at the reference list posted at the end of the presentation. The James Webb Telescope is located at L2, which is one of the 5 Lagrange points in the Earth-Sun system. For that reason, it cannot look inward towards the Earth, Venus, or Mercury. The Sun would damage its cameras. If you see a picture of Earth or Venus from JWST, that is made by AI. But many other Venus-like planets have been imaged and studied, and from this we may learn why Earth is so different than other planets. On Mars, JWST is investigating the migration of water as it moves from ice to the atmosphere and to the surface. It is also investigating mysterious methane plumes that hint at geologic and maybe biologic activity. Asteroids exist throughout the solar system, but the vast majority lie between Mars and Jupiter. JWST has found over 100 new ones there and in other places in the solar system. The metallic asteroid called 16 Psyche was thought to be a core of a protoplanet, but spectroscopic study by Webb has found hydrated molecules which complicate Psyche's history. Water may be present on this asteroid. Failed Webb observations can be scientifically useful, as demonstrated by finding this 100-meter object at over 100 million kilometers away. It is the smallest object Webb has ever found, showing the amazing power of its infrared camera called MIRCAM. On Jupiter, it found a high-speed jet stream 15 to 20 miles above the cloudy atmosphere, traveling at an amazing 320 miles per hour. It is 3,000 miles wide and interacts with the lower atmosphere, creating wind shear. Saturn was imaged with deep exposures to test the camera's ability to image the faint moons and the bright rings. It also imaged a large plume jetting from Enceladus' south pole, feeding Saturn's E-ring. Like nothing we've seen before, James Webb spied on a mysterious asteroid-comet hybrid lurking past Jupiter and Saturn. Named 2060 Chiron, it is called a centaur, and the atmosphere and tail contain carbon dioxide, carbon monoxide, plus methane. Neptune's rings and moons are imaged exceptionally clearly by JWST. Webb's image quality permits these very faint rings to be seen like never before. 7 moons complement this scene, including the brilliant Triton. Uranus is captured in the infrared by the MIRCAM, showing 11 of its 13 rings and many of its 27 moons. The combined blue and orange filter images display the rings like never before and also shows Uranus's polar cap. Webb's spectrograph revealed the presence of carbon dioxide and hydrogen peroxide on the surface of Pluto's moon Charon, seen here in the background. The dwarf planet itself is being investigated, and the references reveal what has been learned about this shunned planet. All slides have listed reference materials on the reference list downloadable with the QR code provided. Please utilize these references for further study. Now, Webb leaves the solar system in search of new exoplanets. Epsilon Indi turns out to be one of the coldest exoplanets ever seen, 35 degrees Fahrenheit. With a mass greater than Jupiter, the atmosphere has been studied and found to contain carbon dioxide, carbon monoxide, and methane. Fictitious planets of Epsilon Indi have been sets for Star Trek episodes, novels, and video games like Halo. Just 20 light years away, the SIMP exoplanet is uniquely called a rogue planet because it does not belong to a star and was probably ejected from a stellar orbit by a collision. Here, in this artist's image, it is wandering through the Milky Way near us, moving at a speed of 1.2 million miles per hour, making it the fastest moving exoplanet ever discovered. I think that rogue robot C-3PO is sitting on the SIMP exoplanet invading our presentation. TRAPPIST-1 is a dwarf star that lies 41 light years away and hosts 7 Earth-like planets orbiting it with a period of from 1.5 to 20 days. These rocky planets have been studied by Dr. Nestor Espinosa of the Space Science Institute at Johns Hopkins University. JJ-1214b is a Neptune-like exoplanet that orbits a red dwarf star and is one of the most studied exoplanets. It is 8 times the mass of the Earth and orbits once every 1.6 Earth days. Its atmosphere contains water and methane, and it reflects a significant amount of light from its host star. Investigation of K2-18b, which is 9 times more massive than Earth, has revealed carbon-bearing molecules including methane and carbon dioxide. This discovery shows that it could be a Hycean exoplanet, one that has a hydrogen-rich atmosphere and a water-ocean-covered surface. Named Kuanka, this Neptune-sized exoplanet is orbiting a Sun-like star, LTT 9779, which is called UBA. It is the most reflective exoplanet known, resulting from its atmosphere, which is very rich in metals and silicates. Few Sun-like stars have a planet that rotates in a time period less than 1 day, making it very close to UBA. Kuanka is also gravitationally locked, with a very hot side facing UBA and the cold side facing outer space. This exoplanet is 10,000 times dimmer than its host star, 2 solar masses and 8,000 degrees K, so these 4 images of the HIP exoplanet taken at different wavelengths is an amazing example of Webb's coronagraph. This allows the light from the host star to be blocked, just like the solar satellites orbiting the Sun obtain data on the solar corona. K2-22b is another Neptune-sized exoplanet with a very hot surface, 3,320 degrees Fahrenheit. This rocky surface vaporizes, leaving a comet tail stretching out into outer space. Astronomers call these very rare objects disintegrating exoplanets, and only 3 out of 3,800 exoplanets have been declared to be in this class. Now 1,200 light years away from Earth, This disk reveals the presence of water on ice-covered dust particles. This planet-forming disk spans a distance of 1,000 times the orbital radius of the Earth and blocks light from the star behind it. The Webb studies it to understand the planet-forming process. Before the Webb investigates the core of the Milky Way and its far outer edges, we pause to admire the beauty and magnitude of our home galaxy. It is 100,000 light years in diameter and rotates once every 240 million years. This person, sitting on the rock, observing the glory of the Milky Way, is traveling through space at a speed of 450,000 miles per hour about the black hole Sagittarius A near the galactic center. Sagittarius C is a region hosting 500,000 stars that are 300 light years towards the galactic center, and the view is 50 light years wide. Both Hubble and JWST have scanned this region looking for discoveries and, in particular, protostars. Taking a closer look, here you see a vast region of ionized hydrogen in blue, two infrared dark regions in the green borders, and a very active protostar system in the central red circle. Initial studies have found 88 molecular hydrogen outflows from the two massive protostars of 20 and 100 solar masses, as well as many other smaller protostars. These flows can extend outward great distances, like 1 parsec, which is 3.26 light years. Moving outward 32,000 light years, Webb's two cameras, NIRCam and MIRICam, observe clouds known as Digel 1 and 2, observing star clusters undergoing bursts of star formation. Here we are looking closer at the region where data on very young protostars, outflows, jets, and nebular features are being collected. These clouds, which span about 12 light years, are a rich laboratory for studying star formation. In the Small Magellanic Cloud, Webb has found brown dwarfs, stars that were born with their nuclear fusion engines failing to ignite. As University of Arizona scientist Elena Sabi said, "We are getting closer to unlocking the secrets of how stars and planets form." These two images of NGC 5584 show the difference between imaging in the optical frequencies by Hubble on the right and imaging in the infrared by Webb on the left. The Webb can pick up much greater detail in the radiation from interstellar grains heated by radiation from nearby stars. NGC 5584 has contributed significantly in the determinations of the Hubble constant, the rate at which the universe is expanding. The Hubble constant has been determined in two ways historically, here shown from 2000 to 2024 by the Hubble and James Webb telescopes in blue and the Planck satellite in red using cosmic microwave background radiation. In 2018, the Planck satellite found it to be 67, while the Hubble telescope produced a result of 74 in 2017. The difference is called the Hubble tension. At that time, Adam Rees, the 2011 winner of the Nobel Prize in Physics, said, "We are using the new Hubble camera like a policeman's radar gun to catch the universe speeding. It looks like dark matter and energy are pressing the gas pedal." By combining the data from these two images, we see a much richer result and a complete data set. So he made an extensive study comparing the Hubble constant from new Webb data to that of the Hubble. These results agree completely, as seen here with Hubble in blue and JWST in red. Yes, Hubble tension remains, as Dr. Rees and others continue to search for a reason for this difference. Taking a big jump into the universe, here at 3.6 billion light years, we find PLCK G156.7, which is one of many beautiful examples of gravitational lensing, or the bending of light by gravity. Like a rock falling on Earth, light falls too, and JWST captures amazing and beautiful patterns resulting from this lensing, sometimes called an Einstein ring. You too, by studying physics and astronomy, could be like Albert Sneppen, a student at the Niels Bohr Institute who studied these patterns and discovered that they were caused by lensing light orbiting around a black hole like a planet orbits the sun, finally breaking free, resulting in the patterns shown here. Furthermore, the three bright dots on the red bands come from lensed light from a type 1a supernova, which is an explosion of a white dwarf star, and this can be used as a standard candle to examine the expansion rate of the universe. This supernova is called SN Hope in the exciting quest to understand Hubble tension. What a fortunate student Albert Sneppen was, and you too can follow his path. It starts with study and research, like exploring the reference list for this slide. Another amazing example of gravitational lensing is this Einstein zigzag, a beautiful Einstein ring. The data and analysis from this discovery refines the Hubble constant measurements and probes dark matter and energy. Here seen is a pattern produced by light from a quasar 11 billion light years away, sending light zigzagging past two in-line lensing galaxies, creating this striking optical pattern. A more detailed look at the pattern from the research paper on the reference list, we see the dots on the ring created as the light is lensed by the nearest galaxy in the center, 2 billion light years away, after being lensed by the further galaxy that's in line with it, 10 billion light years away. Here we see the results of the computer-simulated lensing from this system as the light zigzags through 12 billion light years of time and distance to ultimately be imaged by Webb. This unique alignment occurs only once in 50,000 galaxies, not only creating this amazing zigzag pattern, but it also enhances the scientific potential of the system. Here we see galaxy SPT 0418-47. Astronomers using JWST detected the oldest and most distant complex organic molecules yet in the galaxy. The galaxy is over 12 billion light years away, but from our perspective on Earth, it is directly behind a foreground galaxy that is only 3 billion light years away. The light from the more distant galaxy is bent by the gravity of the galaxy in front of it, creating this beautiful gravitationally lensed Einstein ring. We are talking about big, floppy molecules with dozens to hundreds of atoms in them, said Justin Spilker from Texas A&M University. These molecules occur regularly in outer space on tiny dust grains, but now we have found them in a galaxy more than 12 billion light years from Earth. Many black holes have been discovered by Webb, but the first ever supermassive one was found to exist only 700 million years after the Big Bang. It was 40 million times the mass of the Sun, but even that is tiny compared to others that were discovered later with masses equal to many billion times the mass of the Sun. The three red monsters are Milky Way-sized galaxies formed only 1 billion years after the Big Bang. How did they grow so large so fast? Researchers found that there were no black holes in their centers, which would increase their growth rate. Yet they grew 2 to 3 times faster than later galaxies. The answer remains a mystery. The Deep Field image was first issued and brought great praise globally to JWST. In this image lies another black hole, LID 568, at only 570 million years after the Big Bang. Let's pause a moment looking at the majesty of the deep field. In the deep field, astronomers are puzzled by these massive galaxies just 500 to 700 million years after the Big Bang. These galaxies came out of the Dark Ages up to 400 million years after the creation, when only a cloud of hydrogen atoms permeated space. How did they form so fast? Then, in 2023, Maisie's galaxy was imaged just 390 million years after the Big Bang. This galaxy was named after the discoverer's daughter and at the time was the oldest object ever seen. Surprises continued into 2024 with the JADES observing program that imaged this galaxy. It was younger than 300 million years old. These discoveries at the cosmic dawn lack scientific validation because this JADES galaxy is not like the types of galaxies that have been predicted by models and simulations to exist in the very early universe. Big questions remain. For example, this JADES galaxy is 33.8 billion light years from Earth, and it was created 300 million years after the Big Bang. But the Big Bang was only 13.8 billion years ago. How could this be? What happened to the 20 billion years? Think about that. Could JADES light travel faster than the speed of light? No. Refer to the reference list for the answer. The mystery of JADES galaxies may have been solved by the pioneering work of Catherine Fries at the University of Texas at Austin, with the postulation that JADES 11, 12, and 13, formerly only thought of as being galaxies, were actually dark stars. Wow! These stars are powered by the annihilation of dark matter, not nuclear fusion. She has assembled an international team of astrophysicists, and their work has won the Cozzarelli Prize in 2024 from the National Academy of Sciences. They found that one dark star could outshine an entire galaxy, growing to about several million times the mass of the Sun and being 10 billion times brighter. Wow, this is so exciting that you must read more about these completely new astronomical objects that may exist at the dawn of time on the reference list. Finally, we have reached the ionization horizon only 400,000 years after the Big Bang. This is imaged by radio emissions from the cloud of ions with no atoms present shortly after the Big Bang. Seen here is an illustration of our journey through the universe looking at the many Webb discoveries. We started on the right with the Earth and moved leftward out into the cosmos to reach the early cosmos only a few 100 million years old. Only the Dark Ages, inflation, and quantum fluctuations were left unexplored by the James Webb Space Telescope. We made it through the universe in 20 minutes, moving an average speed of 1,000,000,000,000,000,000 miles per hour. Whew! What a journey for us and 4, the James Webb Space Telescope.
That's all, folks.
But wait, that is not all. On March 8, 2025, the SphereX mission launched, and this new infrared telescope will improve our understanding of what happened in the first second after the Big Bang and search for key ingredients for life in our galaxy. It will join JWST and collect data on more than 450 million galaxies and 100 million stars in the Milky Way. Like two non-identical twin brothers, SphereX and James Webb satellites will work together to advance astronomy and human knowledge of our place in the universe. Thanks for going to the research reference list to follow up. Here's the QR code.